The figure shows the variation of impeller designs that can be used in the fermentation. And mostly the type of impeller being used is the type named as the disc flat blade. This one. And this flat blade, it has 6 plates on the disc. The figure here shows the flow pattern that produced by the flat blade turbine. And you can see here, we need to avoid the stagnant phase. Okay, the radial flow pattern shows here, okay, showing that there is no stagnant phase exists in the fermenter. This is the axial flow pattern that produced by a marine propeller. Okay, axial, you can see here from bottom to top. Okay, bottom to top, and return back to the bottom of the vessel. The selection of impeller can be done by considering the viscosity range. So this figure shows the type of impeller that's suitable for different range of viscosity. Similar to fluid flowing through a pipe, mixing flow regime in a buffer fermenter, it shows in this figure, where you can see here we have a viscous or the laminar flow and the transition region and turbulent flow. Most of the fermentation, we aim for this turbulent flow. And the region can be identified based on the Reynolds number. This typical power curve can be divided up into 3 clearly defined regions, like what we have seen before: the viscous, the laminar, the transition, and the turbulent. So based on the range of Reynolds number, we may identify the range or degree of the region where it belongs. The relationship between these variables is usually expressed in the terms of dimensionless number, which is the impeller Reynolds number, defined by Ni is the impeller speed, the tip speed or the agitation speed, Di squared, Di is the diameter of the impeller, Rho L is the density of the fluid, the media or the broth in the fermentation, over mu L, the viscosity of the fluid.